Okay, so today's lesson is going to be on upper and lower bounds, but it's pretty much a recap because we did this last Thursday, and some of you have notes in your books already, but some of you need some help with this because you weren't in on Thursday. Now, the aims of today's lesson is firstly, go through the test. I've attached the tests to Teams, so you need to find your test, check to see what your mark is, go through your corrections, use the video solutions that I've uploaded to Teams as well, and just make sure you know what's going on. And if you don't, then you can post a question in the Teams chat and I'll get back to you as soon as I can. But let's just assume you've done that. And then we're going to go through this upper and lower bounds, and then you need to get 100% on a My Maths task which I've set. And if you have forgotten your password or you don't know what it is, then I have put all of the passwords on Teams in a folder labelled passwords. So you can do that, no excuses. So let's just get straight into it. So pretty much upper and lower bounds is all to do with rounding. So if I gave you a number which had been rounded, so e.g. number 1, say 3.5 has been rounded to 1 decimal place. Now all upper and lower bounds ask you to do is to find the lowest possible number, which has been rounded to 3.5 to 1 decimal place, and the highest possible number that has been rounded to 3.5 to 1 decimal place. So find the upper bound and lower bound. Now rounding, when it comes to 1 decimal place, is you would focus on the first decimal place, which is the 5, and you would always look at the number next door and decide whether you round up or leave it as it is. And the number next door is a 0 in this case. But you want to find the lowest possible number that would round up to 3.5 and the highest possible number that would round up to 3.5 or round down to 3.5. Now, the rules of rounding in this case would be you're looking for 5 or more rounds up, less than 5 stays as it is. And you make use of that. 5 or more rounds up, less than 5 rounds down. So I go less than 5. And I subtract 5 from the number next door. So that drops down to a 3.45. And that would be the lower bound. 3.45 is the smallest number that rounds up to 3.5. And the upper bound would be adding 5. 3.55. Again, adding 5 to that number next door to the 5 to give you 3.55, and that's called the upper bound. And that is, well, not technically it's not the highest number that rounds down to a 3.5 because that would actually round up, but every number less than it, so 3.549999999 so on, that would round down to 3.5. So this is called the lower bound, this is called the upper bound, and the best way to write it is as an inequality. So if I said that number at the start was x, and that x had been rounded to 3.5 to 1 decimal place, x would have to be a number which is bigger than or equal to 3.45, but less than 3.55. And that's pretty much it. And the bit on the left is the lower bound, and the bit on the right is called the upper bound. And that's all we did on Thursday. Try another example, e.g. number 2. Let's pick on the number 6,300. And let's say that's rounded to the nearest 100. Okay, and I ask you to find, again, upper and lower bounds. Now if you're rounding any number to the nearest 100, you should focus on the hundreds column. Okay, and you would look at the number next door. So in this case, the 0. And if that was 5 or more, you round up to 6,300, or if that was less than 5, you round down to 6,300. So we can use exactly the same trick as above. That number next door, if you subtract 5 from it to get 6,250, or add 5 to it to get 6,350, you get the upper and lower bounds. That's called the lower bound, that's called the upper bound. Could write it as an inequality, x, call that number at the start x again. It has to be greater than or equal to 6,250, but less than 6,350. Lower bound, upper bound. Now they might ask you to write this inequality on a number line, and if you had to do that, draw your number line, put your 6,300 in the middle, put 6,250 to the left and 6,350 to the right. And this inequality, well, less than or equal to, so a circle which has been coloured in, a solid dot for the equal to, an empty dot or hollow dot for the less than, and you just join those dots up, and that would be 6,250 is less than or equal to x, which is less than 6,350 on a number line. I'm going to do one extra example, e.g. number 3, which I didn't do last time, which was rounding something to the nearest 5. So if I gave you the number 25 to the nearest 5, I'll ask you for the upper and lower bounds. You can't use the method I've just discussed, because the rules for rounding to the nearest 5 are a little bit different. 5 or more, less than 5 are stuff for rounding to the nearest 10 or decimal places or significant figures. To the nearest 5, completely different. Okay, so this one you're just going to try and use some logic. So think about what the smallest number would be rounding to the nearest 5, and also the biggest number that would round down to the nearest 5. And kind of what you can do, because it's to the nearest 5, everything's sort of halved, so rather than subtracting or adding 5, you subtract 2.5 or add 2.5. Everything gets halved. So the lower bound would actually be 22.5 and the upper bound would be 27.5 or 27.499999, but that should be fine. So lower bound, upper bound, and those ones are a little bit different. Again, call the start x. X would have to be less than 27.5 but greater than or equal to 22.5. In other words, if you are rounding to the nearest 10, 100, 1,000, 1 decimal place, 2 decimal places, 3 significant figures, 2 significant figures, you can just use the rules from EG1 and EG number 2. But if you have to round to the nearest 5 or something else weird, maybe the nearest 25 or something like that, you have to use a method like this and be a little bit more flexible with what you are subtracting and adding. Now, I'll say it again, what you've got to do now is go to My Maths, go to complete the My Maths task at 100%, and if you have any questions, please post them on the Teams chat by the end of today. I'll get back to you.